Hi, welcome back to another Math 9 video. Today we're doing 6.3 linear inequalities. So we're going to start off with just sort of reviewing the symbols for inequalities. And in this first example, true or false, this is saying -6 is greater than or equal to 2. So we know that that is false because think of on a number line. -6 would be in the negatives to the left of the 0, and +2 would be to the right of 0, so it's false. Is 0 less than or equal to 5? Yes, it is, so that's a true. And in this one, it's saying -3 is greater than or equal to 3, so we know that that is false. And maybe a good way to show all of these is just to do a quick recap of a number line. So if we have 0, -1, 2, 3, 4, 5, 6 would be there. 1, 2, 3, 4, 5 would be over there. So when we're comparing them, -6 is over here and 2 is over here. So you can see the reason that the first one is false. And 0 is here and 5 is here. You can see that 0 is less than 5. Anything to the left of a number is smaller than it. Anything to the right of a number is larger than it. So that helps you to sort of get a sense of what this is referring to. So similar to what I just sketched, if we want to graph this out, we would be graphing it on a number line. I like to start with 0 in the middle. And it says x is greater than or equal to 3, so we would go 1, 2, 3. I draw a circle there, and because it says greater than or equal to, that's what the line underneath means, I do color in my circle. X is greater than means I want to include all the numbers to the right of 3. So 4, 5, 6, etc. would be on here going on. And so that's how I basically show my solution for this. X is less than 1. So again, on my number line, if I have 0, there's 1. There's 2, there's -1, so you get a sense of where the values would be. So if it says x is less than 1, I draw a circle at 1. This time it doesn't have an equal to sign underneath, it just says less than. So I leave it open and I don't color in the circle. And if we're talking about less than, then we would go to the left of 1. So this is how we would graph out our solution to this. For the next one, x is less than 2. Okay, so let's do 0, 1, 2. I draw, well, there's 3, an open circle. If x is greater than 2, I think I might have just said less than. X is greater than 2 because the symbol is open to x. Then that would mean that I draw an arrow going to the right of 2, like this. And here, write the inequality. So we're sort of doing the opposite. We're given the graph or the number line, and we want to interpret and write down what that means. So if we are at -5 and we're going to the left of -5, I would want to say x is less than or equal to -5. That's referring to everything to the left of -5. I did this equal to line because of the fact that the circle is colored in. Okay, in the next one it says a number is at most 5. I want to graph this on a number line. So I'd have a 0 here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, -5 down there. If it is at most 5, well, we want to think our way through this. If it is at most 5, that's saying it's the maximum is 5. Do I color it in? So can it be equal to 5? If it's saying it is at most or the maximum is 5, then yeah, it could be 5. Or it could be anything smaller than 5. So I'm going to draw an arrow going to the right to represent that. For the next one, 4 more than a number is greater than 5. 4 more than a number would be, let's say the number is x, it would be x plus 4. We're saying that is greater than 5. So greater than 5 would be represented like this. So we're translating a sentence into math. And that's it for today. Numbers 1 to 6 all is your work.